In this lesson, I will walk you through this problem of belt drive. This problem, it reads as follows. The following information is given for a flat belt drive. Diameter of the driving pulley is 450 millimeters. Rotating speed of driving pulley is 50 rotation per minute. Contact angle of a belt is 170 degrees. The coefficient of the friction 0.3. A safe working stress is 2.5 megapascals. Mass of a belt is 0.25 kg per meter length. Assuming that the belt is 15 millimeters thick and 100 millimeters wide, calculate the power which can be transmitted. Let us extract all the data from this problem. We'll separate here. The driving pulley has got a diameter. The diameter is 450 millimeters. Then that is 450 millimeters for the diameter, which is a driving pulley. Then the rotating speed of a driving pulley, it is 50 rotation per minute. It is N is equal to 50 revolution per minute. Then we have a contact angle, which is 170 degrees. Then we'll write it is 170 degrees, the contact angle. Then we have a coefficients. This is coefficients of the friction. It is 0.3. Then we have a stress here. Stress here, it is 2.5 megapascal. Then we've got the mass here. The mass is 0.5 kg. Then we've got the thickness here. It is 15 millimeters. Then we've got the width here. It is 100 millimeters. That's the data that we have. We are required to find a power. To find power, we know that the formula for power, it is power is equal to open bracket T1 minus T2 close bracket times the velocity. So we have to find T1, we have to find T2, we have to find the velocity. First, let us calculate the tension 1. To calculate tension 1, we will use this formula. T1 is equal to stress times the area, like this. So here, this area is the area of a belt. It's not the area of the wheel, it's the area of a belt. So this area of a belt, we will find it by, let me write here. Here it's the area of a belt. It is equal to the thickness times the width. We have to convert this thickness into meter. So this thickness, it is 0.015 meter, and this width, it is 0.1 meter, like this. Then we take it to substitute here. This, the thickness, it is 0.015 times the width, it is 0.1. Then 1.5 times 10 to exponent 3 meter squared. That is a area that you're gonna use here. Then let us substitute here to find the T1, the tension on the tight side. The stress here, we have also to convert a stress here. 2.5 times 10 to exponent 6 Pascal. It is like this. Convert it to Pascal. Then we'll put it here. Then when you calculate this, it's gonna give you the tension to be 3 3,750 newtons. That's the tension one, you got it. This, don't worry about this. 245, don't worry about this. It's the same as that I wrote there, 2.5 times 10 to exponent 6. It's the same like this. Then from here, then tension 2 here, gonna use the formula to calculate the tension ratio. But the formula that we're gonna use, it includes the centrifugal tension. Like here, it is T1 equal to T2, then Z minus the centrifugal tension. The centrifugal tension then is equal to E to exponent coefficient times the contact angle. The coefficient here it is, then the contact angle here it is. You have to convert it to rad. So here we have to find this, the centrifugal tension. Here we say centrifugal is equal to, it is a mass times velocity squared. So let us find the velocity first. The velocity here it is pi times, then we say d the diameter plus the thickness times the rotational speed. It is like this. Then you substitute here. The diameter is 0.45 plus the thickness 0.015. Then the rotational speed here, let us convert to the rotational speed first. It is 50 rotation per minute. Then we put 1 minute on top, 60 seconds on the bottom. We get 0. That's how we convert it. We take it to put it here. It is 0.833. Then when you calculate this, it's gonna give you the speed to be 1.29 meters per second. That's the speed. We take that speed, we put it here to find the centrifugal tension. The centrifugal tension, it is the mass. The mass here, it is 0.25. The mass is 0.25. Then we put the velocity here. It is 1.29 squared, like this. Then when you calculate this, the centrifugal tension, it's gonna be 0.42 newtons, like this. From here, continue here, we find the centrifugal tension. Then let's take back this, our tension ratio formula. E to the power, the coefficient is 0.3. Then let us convert the contact angle to rad. It is 170 degrees divided by 57.3. That's how we convert to radians. So this is gonna give you 2.967 radians. Then you take this radians to put it here. Then from here we substitute. We got a tension one here. It is 3,750 minus the centrifugal to be 0.42 divide tension 2. We don't have tension 2 that we are looking for. Then the centrifugal is 0.42. Then this whole of this term, it gives us 2.44. 3,750 minus this 0.42, it gives the 3,000, this T2 So T2 here, we finally find it to be 1536.29 newtons. That's the tension on the slack side. We found the tension 2. We found the tension 1 to be 3750. That's the tight side tension. Then the velocity, we found it to be 1.29 meters per second. Then that's what we've been looking for to find the power. So we have this one, we have this one, we have this one. Let us substitute. The power that we get there, it is 2856.06 watts. It's 2856.06 watts. That's the power that they've been looking for. We found it. So all the way down. So the power, it is 2856.06 watts. That power, been looking for this one. It can be transmitted. So recap on this problem. This problem, we've been looking for a power transmitted. So to find this power, we have to find tension 1, tension on the tight side, tension on the slack side, and the velocity. So we firstly find a tension 1 using this formula, which involve the stress. Here, this stress, the megapascals one. Then the area of a belt is not the area of a wheel. This one's the area of a belt. So we've used this. We've used this width and also the thickness to find the area. There where we did it, then we found it to be this number, the area. We take it to substitute on this formula. From here, we put this 2.5 megapascal. We converted it to Pascal. So it gave us this number. This number is the same as this number, 2.5 times 10 to exponent 6. Then this area, then we get our T1 to be 3750 newtons. From there, we have to find T2, this one. So we use this formula to find the tension ratio here, but this formula, it involves the centrifugal tension, which is TC. That's the centrifugal tension. This one, T. So we use it. The coefficient here, it is 0.3. If I'm not mistaken, yeah, the coefficient is 0.3. Then we converted this angle of contact to radians. You know that when you convert the degrees to radians, you simply use these degrees, then you divide by 57.3, like this. Here on this side, you put the degrees. That was 170 for this problem. Then we got angle of contact in radians form. Then we converted the speed here, the rotational speed here, to be per second, like this. We've used this. Then from here, we take this rotational speed, we converted. We used here to find this speed of a belt here, where we use the diameter and the thickness of a belt, and that rotational speed that we've been converting here. Here we converted it, the diameter of a wheel, the thickness of a belt, then we get the velocity for the belt. From here we take the velocity of the belt, we put it here in centrifugal tension formula. This is mass. Then put mass and the velocity, we got the centrifugal tension. Then we substitute here, all here, we substitute. Then finally we get the tension 2 to be this number. Tension 1 we have the velocity. Then substitute on the power formula, we get this power that was transmitted.